disgusting. So in the world of ideal forms, you want to answer this question. How do you answer this question? Well, it requires a certain leap of faith without any really basis in logic or anything. The Greeks made leaps of faith all the time, just like students in every math class. They're required to make leaps of faith. This is a leap of faith. Take this circle. Let's chop it up into 2 parts, 4 parts. If I drop it up, this makes it easy. It's like a pizza. So if and we always have to be fair because, you know, I have kids. So let's just keep chopping it in half. So first 4 parts, and then how many parts do I have? 8 parts. Let's just do 2 to the n parts. So chop with a circle or disc into 2 to the n. That means 2, 4, 8, 16, 32 parts. Okay? So, now, so here's a chopper. How many do I have? 8. Okay, I have it. So now, let's take the center point here. So here they could bisect an angle. And now they could draw a tangent line here. The Greeks knew that the tangent to a circle was always at a point was always perpendicular to the circle. So this is a right angle. They certainly knew that. That's a right angle. And okay. So let's call this L1. Let's do this for each of the regions. Let's call this L2. Let's do it here. And let's call this L3. And we just keep doing this. Okay? Now, whatever the length of the circumference of the circle is, we know that this is a polygonal region that surrounds the circle. Okay? Now, now we have to ask for an intuitive leap of faith, almost like a religion. The intuitive leap of faith is that if I cut this circle up into more and more and more parts, the length of this, now is this a problem, the length of the line? The length of the line for the Greeks was not a problem. And it's very easy to understand why that would be the case. So the length of the line was not a problem. So I could take this length, and this length, and that length, and that length. Obviously they're all equal, but let's ignore that for the moment. I take all these lengths now, and I add them up. So, leap of faith, I can take L1 plus L2 plus, let's say I get 2 to the n of it. Now, I've done nothing difficult. Yeah?
In this example, that would be L8, right?
L8.
Okay. Just wanting to make it more.
L8. Or in general, L1 plus L2 plus the dot, dot, dot just means I'm eliminating the middle terms. Plus dot, 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 L to the 2n.
You're not writing them down, but they're there.
Right. I'm not writing them down. I'm showing their existence by 3 dots. That's a mathematical convention. Just because, obviously, if n is a million, I would be here all day, all night, and for the next week. Okay. Now, everybody understands the length of a straight line. Now, what's the intuitive leap of faith? The intuitive leap of faith is as the number of choppings gets larger and larger, gets larger and larger, that means as n gets larger and larger, these lengths get closer and closer to some number. And we define that number to be the circumference of the circle. If this is true, we define this number.
Shouldn't it be the sum of these lines?
What is,
This-
the sum of these
The
lengths.
lengths actually get
Yeah,
smaller.
the sum of these lengths. The sum of these lengths get closer and closer to some number. We define this number to be the circumference. Now, why would someone expect this to be true? So you can see now, if I draw another circle here, let me draw another circle. Let's get rid of the similar triangle, and let's get rid of the intuitive principles of area and number, and raise everything to a big. I think I'm responsible for these big erasers. But somebody forgot which side is up and down. They used both sides. Okay, so you can see that if I take this circle now, here, hey, how's that circle?
Wow.
I rarely can do something like this. I heard that, I think it was Michelangelo that made a perfect circle. Okay. So now, if I draw many chops, okay, let me not do all of them. Let me just do here. Oh, I can't even draw that. Now look at this. Here are the L's, here in this case. You see them? Now, if you draw them very small, you can believe that the sum of these lengths is going to get very, very close to the circumference. Now, what happens? What do you think happens when I chop this up more and more? What is going to happen to the sum of these lengths? So they're going to, this is, the sum of these lengths is clearly going to be greater than the circumference. What's happening to the sum of these lengths? That's right. They're going to get smaller.
Because the lines won't stick out from the circle.
Right. So let's suppose I do 2 choppings. I have a number. I do 4 choppings. I get a smaller number. I'm moving now along a number line to your left. So I'm going negative as far as you're concerned. Right? I'm going in the negative direction, right? I do 4 choppings. I move again. I do 8 choppings. I move again. Now, however, I'm not moving out to the chancellor's house or to the building across the street. Why not? Because the sum of these lengths has to be bounded by some number. In particular, it's bounded by 0, right? So I'm prevented to go to the end of the room here, let's say. Suppose that's 0. I'm always, at each stage, I'm moving to my right and to your left, but I'll never reach that door, which is 0. Now, this is the fundamental link between area and number. Everybody believes heuristically that there is an area. Everybody, there may be people somewhere that don't believe it, I don't know. Anyway, so now, and we calculate the area, I'm taking choppings and I'm constantly moving to the right. But I can't move all the way to the right. I can't get beyond that door. So intuitively, I have to keep going. It's like the pendulum.